As you can tell, I'm not native, so that makes me feel quite slightly more nervous than usual. And so I don't want keyboard setup assistant, whatever. And so I decided literally a minute before getting on stage that I wanted to try and have the most fun of this. So we'll see how that goes. But anyways, thank you all for coming, and especially to Michelle, Rebecca, and the whole G2I team for having me. I'm Valentina. I'm the head of development at Basement Studio and the co-author of XMCP. You can see the screen right? It's a high-speed framework for building and shipping MCP servers. And I was actually sitting in the audience at this conference the very last year. So today I'd like to walk you through the project that I've been building since I've gotten back from it, and more importantly, the path that led me back in here. At Basement, we design brands and build web experiences, mostly using React and Next.js. So we're always raising the bar and pushing the limits on what's possible. And because of that, is that a lot of our internal processes are constantly being rethought and redesigned. And that basically means we are always experimenting. And it is throughout that experimentation that we started noticing something, which is a big part of our pipeline was repetitive and slow, things we were doing over and over again. So we started asking ourselves, like, how do we automate this? Like, how do we make this faster? How could we start building the tools for ourselves? And that's when we started exploring internal agents. And this was around May 2025, so MCP had only been around for about 6 months, still very early. And for those of you who aren't familiar with MCP, it's basically a protocol that lets you expose tools and capabilities to AI models in a structured way. And so now apps that were isolated before can now connect to LLMs, and that's basically how you go from an AI model that chats to a model that can actually do things. And for use cases, that was really compelling, actually. But as we started building with it, is that we run into a lot of friction. And the thing is, we're used to the web. We're used to things being simple, intuitive, well-documented. You spin something up, deploy it, and it just works. And this didn't feel like it. This felt like even getting started felt harder than it should be. And this is where our background really shaped how we saw the problem. Like, at some point, we made a decision to pivot. And instead of continuing to build just our internal tools, we stepped back and asked ourselves, like, how would this look like if we were building for the web? I mean, we cannot be the only ones struggling this much, and in fact, we weren't. To really understand why this felt so difficult, I'd like to briefly walk you through what building with MCP actually involves. And I mean, not everything, I mean, just the parts that matter to the story, because on paper, it may sound simple, but in practice, there are a few core concepts that you really need to understand before even getting started. So, for example, like you got transport layers. How does your server communicate, whether it's through STDIO, servers and events, HTTP, where and how you run it, whether it's a local or a remote one, where do you deploy it, how do you structure the different capabilities, you got tools, you got prompts, resources, and how it all connects. I mean, how do you connect to a client and execute and call a tool? And then basically everything around it. You got to add authentication, payments, orchestration. And it is not like each individual aspect itself is that complex, but when it adds up, well, it is a lot to handle. And to my understanding and how I like to think and face different problems, I should be thinking about the end result. I shouldn't be worrying about all the noise around it just to make it work. And that's when it clicked. And this wasn't just an educational problem. It felt like something much more fundamental was missing. Like there was a lot of work left to do. And that's when we decided to focus our efforts into building a framework. But why a framework, you may ask? Well, one of the main things that we wanted to do is to leverage the protocol, right? We didn't want to be strictly tied to the specification alone. We wanted to have flexibility and robustness, and so building a framework basically fit our needs because that gave us a lot of control. And we took a lot of inspiration from building for the web for it. For example, since we were rebuilding the transports from scratch, we could inject and intercept requests however we wanted. And that unlocked basically building a middleware layer in which we could add payments, authentication on top of it, easily using custom native integrations. We also had full control over this compiler, and we built watchers around it to spin up a dev server so we could listen to file changes. So suddenly we are building a bunch of elements and interactions on top of the basics and really shaping the framework into something that could scale with zero boundaries whatsoever. So pretty much every single thing that we wanted to do became totally doable. And on one end, that's super fun. On the other hand, you're solving problems no one's ever solved before. And that's super fun too, but also incredibly frustrating because you don't know where to start, you don't know the right solution, and every single decision that you make will impact in the upcoming ones. So you have to balance being conscious about the decisions that you make while still allowing yourself to fail and start over. Okay, but so far we only got the main idea. Like we covered the problem, we covered the solution we went for, but what does this all have to do with React? Well, one of the bets that we made from the start was UI. Tools are not simply function executions, but they could be used for rendering UI. And that's a whole new paradigm shift, because I'm picturing generative UI or platforms being entirely rebuilt for agents as the main users. But again, this is a backend framework at most, so how do we add a UI and why? Well, GPT apps at the very beginning pretty enforced this paradigm shift, and that later became standard, and so pretty much every single client nowadays supported, and it is basically the most common use case onto how you could be injecting UI into LLM jets. So now you find yourself interacting with products through LLMs and not through their platforms per se. And if you're building a product, you have to be building the blocks the user would use to shape their experience to their needs. Take a set of predefined actions or even generative UI, you get to decide how and what you want from the product, and it no longer enforces the same UX for everyone. That's pretty cool. So how do we do this? We need to pass specific metadata that the clients use to instantiate iframes that inject content. In this particular case, we're returning template literals. On the left side, so you can see, we need a resource that's responsible for serving the UI. Our tool, on the other hand, simply returns metadata that points that resource to the client, and it can render it. In terms of DX, it worked, but it's not that straightforward, right? So I iterated on this. And this is the fun part, again, about building a framework, because I get to modify the syntax to what I want it to look like. And that was pretty much my train of thought throughout this process. Like, I would start by building the syntax, like the end result, and then I would abstract it and reverse it back into the framework. And that's when I figured, OK, I want to make this simpler. How can I do that? And the protocol under the hood still needs both files, both the tool and the resource. But what if I somehow detect I'm building a UI tool and auto-inject the resource on the framework side? That could work. So now I'm left with a single file to return UI from my tools. But so far, we only got template literals working. I don't want to be building my app somewhere else. What if I want to build widgets, components, whatever my app needs, simply through my MCP? Like, I want to be using the same entry point for basically everything. Like I mentioned, I've got all my layers in here. I also want my UI in here. This was literally the first slide I put on my talk before even writing about it. I knew I had to have this somewhere. But after all, we're front-end developers, right? We're obsessed with the web. We're experts. We build an enormous amount of interfaces, optimize them, polish them, added amazing animations on top of it, 3D models. So what's the breathtaking here? And that's got to be React. But it's not that simple, though. And particularly, this was one of the most fun yet complex problems that we solved. And to be completely honest, we were building this mostly from scratch and writing all the code ourselves, like by hand. So this is where I'm going to get technical. Again, you got to keep in mind we're building this on top of a backend framework. And our goal here was simple, basically, to make it as easy as possible to render a React component from a return tool, right? So we wanted to inject the syntax. So we had to have the framework somewhere. But we figured we didn't want to enforce the shift entirely towards UI. So after some back and forth, we decided to keep it as an optional dependency. And you simply have to turn your handlers from TS to CSX. But again, it's not like you can just change the runtime and expect the syntax to work. Let's remember, the handler from tools is just a function that runs on a server. So we've got to normalize whatever it returns into a valid tool result. And to handle these cases is that we had to split our workflow in two, depending on the file type. For TS files, everything stays server-side. We still have our original bundler and runtime that handle returning text or structured data. React comes in as the next layer then. It is a build time that we generated a browser entry that knows how to mount the React component. We basically find all of these TSX files, compile them into browser bundles, and store them in the build output. Then at runtime, instead of trying to execute that React component on the server like a normal tool handler would do, we replace that, the normal execution path, with a stub handler that simply points the client to that component. So for these tools, the server's not rendering React at all. It's basically just saying, here's the widget, here are the arguments, go find it. It basically acts like a pointer. And under the hood, here's how the HTML shell gets generated. Basically, we got a function that receives both the JavaScript and CSS and returns an HTML page. If there's CSS, we inject it directly into a style tag in the head. And instead of pasting the JavaScript, we turn it into a blob and import it at runtime. So you may say that effectively, React code runs as a real ES module. And the widget, of course, also has to handle the MCP UI handshake with the host. So far, we just tackle how to render React on a browser. So this handshake basically is just an exchange on events where it posts an event which says initialize to the client waits for the response from the host, and then it confirms again with a notification saying, OK, you're good to go. And the rendering responsibility is fully shifted to the client. So what you end up with is a fully self-contained component. And that's pretty much how we solve one of the most breaking changes the framework has had. And it did change how we scale it. And for a while, we even thought about shifting entirely, like going all in on UI. But what actually made this part interesting wasn't just the solution itself, but everything that came with building it, you know? The minute I put up this slide, I realized every single PR that I put in here didn't pass the CI checks. And some of them were merged anyways, but never mind. Ignore that. We broke this many times. We rebuilt it from scratch more than once. And I mean, our first guess was to generate the HTML that would inject the React ESM script from the web through a CDN. So we would have to go and read the package.json version the user had, inject it. We were injecting React in every single bundle we were generating. That didn't scale. We then figured, OK, server components. Well, clients don't support it. And we then added virtual modules to the compiler for temporarily persisting the bundles and referentiating. That didn't persist because most of this ran on stateless environments. So anyways, I guess what I'm trying to say is eventually it stopped being a technical problem and about making it work. And it was more about understanding the consequences of the decisions we were making, like how would this scale, or what kind of patterns am I trying to enforce or encourage people to adopt. And at some point, you realize you're not just building a feature, but also shaping how others are going to interact with your product and how others are going to build on top of it. And that makes you think about a different set of questions. Am I building this in a way that only makes sense to me, or am I building something that other people can actually pick up, understand, and use? Despite of that, I guess one of the main realizations that I got to throughout this project, it is not strictly technical stuff that I learned, or about how to ship an open source project, how to build a community, how to scale it, or how to monetize it. It's more about building stuff that you want to see in the world. And it was actually last year, the very first time I attended this conf. And it was so inspiring to be there, listening all these talks, asking to myself, like, how cool would it be to be building something I could share with the world? And this is where I'm going to get quite cringy and personal. But I went to college for civil engineering, and then I switched to a systems engineering degree, and eventually I dropped out. And I guess I always wanted to build something and get to see it in the world. And this is the case. Like, see it come to life, you know? Back then, it was buildings and bridges, and that turned into software and tools that people use. And I mean, it is so cool to build something that people use on their daily basis. And in everything that I do, there's a little part of me then. Because there's a lot of time invested, a lot of effort, a lot of trouble in the process, you know? And seeing all that stuff come to life is actually super rewarding. So today, the framework is actually, well, it's listed natively as one of the frameworks from Brazil, and it's also used in production by leading companies. The one I'm most proud of has to be Red Bull, but that's just because I'm a huge F1 enthusiast and particularly a Verstappen fan. There you go. I simply love that man. But anyways, I guess what I'm trying to say is, and what I'd like you guys to live with from this talk is, I'm just a regular person that once sat there and I got to do this thing simply because I kept on trying and working. There's no matching in the process, no talent whatsoever. You just got to keep on pushing and remember to enjoy the process. It is an honor to be here closing the schedule today. I don't know if all of you are aware, but this is Michelle's last conference. So I wanted to wish her the best on what's next. And she trusted me on my first talk, so I'm super grateful for that. And also congratulate Rebecca, because she's going to take the lead on next year. So yeah, that's pretty much it. Thanks again, and we'll see you around.